Welcome to ArcGIS Pro SDK for .NET, beginning editing with focus on edit operation. My name is Sean Jones. With me is Narelle Chedsey. We are both on the desktop editing team in Redlands, California. In this session, we're going to be talking about editing in Pro with SDK, cover the basic edit operations, workflows and usage, the inspector class to access and update attributes, and then we'll finish off with editing events, looking at row events and edit operation events. So let's start off with edit operations. If you've had a chance to look at the UI, it's pretty easy to make an edit. You can simply create a new feature or select and delete a feature. And you'll notice that you don't have to start editing to do that. Typically when you do that edit, it will go on the undo stack and you can undo and redo it. And it's also started what we know as an edit session. And so that edit session is created for you and it stops when you do a save or discard. In the SDK, that is covered by the edit operation. That's the main class that does actually the work. It performs three key functions. It provides a coarse-grained API that we use for all your editing. So it has a bunch of properties and methods to achieve edits in Pro. It consolidates multiple edits into a single operation. So if you're doing something like 100 creates or 100 deletes, you can get them consolidated onto one operation that appears on the undo stack. And also, more importantly, it actually maintains the edit session for you. So if you're not in an edit session already, it creates one for you on the workspace, leaves it open until you do a save or discard, and also maintains all the caches that we have in Pro, so the display caches, the data caches, etc. And it'll do that across workspaces and maps. So it does quite a lot of stuff. And importantly there, the key point on the bottom there is that if you've got multiple data sets across different workspaces or data stores, as we call them, it maintains all the caches and make sure everything is in sync, if you like. So how do we use an edit operation? The basic workflow is we create a new instance of it, and then we specify the edits to be performed. And this is really queuing up all the edits to be performed. And then we simply execute that operation. So we execute all those edits that we've queued up. And we'll go through these one at a time in the next few slides. So instantiating a new edit operation, simply with a new keyword, new edit operation there. And then the edit operation itself has a bunch of properties that can be helpful to you. The most obvious one there is the name of the edit operation. This is the string that's used in the undo redo stack when people see it in the drop-down on the UI. Select new features is important. Select modified features if you want those features to be selected after an operation, whether it's be created or modified. The error message can be helpful if the edit operation fails for some reason. If we know what the error message is, we bubble it up to you. Progresses will only show if the operation is taking longer than 2 seconds. So you can show a progressor there to your user to give an indication that something's actually happening. There are other ways to do progressors as well outside of that operation, but we won't cover that as part of this session. Example on the bottom there is saying how we set up a new operation with some of these properties. So in terms of the workflow, this is how we actually perform edits. On the edit operation class, we have a lot of methods to actually achieve edits. Most popular are create and delete, of course, but you also have move, modify, and all. Essentially, we have a method for each command that we see on the actual UI itself. So the obvious, more common ones there: clip, reshape, cut, etc. You specify the method and also the parameter to achieve that particular edit. In most cases, it's the layer or the feature that you actually want to make the edit on. And the way we specify it then in Pro is normally by something called a map member, which is normally a layer in the map, or it could be a standalone table, and an OID. So what OID, what feature in this layer are we actually going to create, modify and delete? Create's a bit different. We can create it from a template or just bang it straight into the layer. And there's a lot of parameters, a lot of overloads going on as well. I think create alone has something like 12 overloads. A couple of points to keep in mind. The operations can be performed in any combination. There's no limit to how many you can have. So I can put in 1,000 creates here, and maybe 100 creates and 10 deletes. The operations must be specified independently of each other, so you can't really rely on an operation that's happened before, or a line that you've set in the operation before the next one. For example, if I do a buffer and then I do a clip, I can't rely on the fact that the buffer's actually been run before the clip. And there's a lot of other operations which say I need the OID for something, so I can't do a create and then rely on that OID being there within the same edit operation. And there's ways to get around that we'll see in a few other extra slides. You can't nest edit operations, so I can't create a new edit operation and then create another one inside it. That will lead to bad things, so just don't do that. And this example is down the bottom of how we use these methods with some parameters. The execute is how we actually run all these methods that we've queued up, all these edits. They're executed in a predefined order regardless how we declared them in the code. So there's a small list there, so the corrects get run first, the updates, and then deletes and reshapes and clips and so on. The success, if it succeeds, if the edit operation works, then it gets placed on the undo stack. You get one item on the undo stack for every successful execute. If it doesn't succeed, then you won't obviously get anything on the undo stack. But more importantly, if you rack up a whole bunch of methods in your edit operation and one of them fails, then we just fail them all. So if you had 100 creates and the 99th one fails, then we'll just fail all the preceding ones because we don't want to leave the editor in this half worked, half not state. You can check to see if an edit operation actually did succeed by looking at the return value on the execute itself, which is just a Boolean. There's also a property called isSucceeded on the edit operation to check there. And as I said before, if there's any reason for a failure that we know about, it'll be shown in the EditOperation.errorMessage property. That's if we know it. Sometimes we get messages back from the geodatabase which we just don't know what happened, or the message is a red herring, for example. And here's a sample, or example of just a simple edit operation. I'm setting one up to make an edit. So I define the properties, specify the methods of the edit that I want to perform, and then I simply just execute it at the end there. And I'm checking to see if it succeeded, and if it did, I might want to do something else. And if it didn't, I might want to do something else as well to work out why it's actually failed, or message the user, as the case may be. Chaining. This is a more advanced concept. So we said that the methods must be independent from each other, and the classic example that we use in the old days, I guess, is adding an attachment. So if you take a look at the syntax for adding attachment, it requires an OID. So in the same edit operation, what I can't do is create a feature and return the OID from it, and then use that OID as a parameter for the add attachment, because I don't know what it is. I don't know what the OID is going to be until the execute actually runs. Now I can get around that with that attachment case by running two edit operations. There's no limitation to doing that. So I might run one edit operation for the create, get the OID back, run the second one for the add attachment, and that will be fine. But because I'm running two executes, I'm getting two items on the undo stack. So what I can do is use what we call a chaining operation to link a new edit operation to the one that has been run. And all that does is run the two edit operations independently, or the second one independently, and just adds it to the undo stack that's already there for the first operation. So when I undo it, it just undoes both edit operations. So looking through the text there, use it if require is dependent on the results of the previous edit operation, and you want to combine the groups of edits to be treated as one item on the undo stack. That's the important part. If you don't really care about the undo stack, then you can certainly run multiple edit executes, and that's fine, but just be aware that you are going to get those multiple items on the stack. Syntax to create one's pretty easy. You just take the existing edit operation reference that you have and use the method create chained operation. And then you can just use the regular edit operation methods that you've been through. Example of that is that add attachment case where you can see at the top here I've created an operation, I do the create facilities there. We're using an action here to return the OID, and that's what we're getting out of the create, and so we're storing that. And then we're saying if that succeeded, if the execute actually returned true, then we're creating a chained operation, and then we use that reference as the new edit operation, and we just simply say add attachment, use the ID, etc., and execute that. And we should get a facility being created and the attachment being added. Once you've made all your edits, you can leave it up to the user to save or discard, or you can call it through the SDK, and that's simply just saying on the project current save edits async or discard edits async. It's an all or nothing procedure, so all edits across all workspaces in all maps will be saved or discarded at the same time. So it's up to you whether you want to do it as part of your workflow or just leave it up to the user to do. All right, let's take a look at a simple edit operation. What I've done is I've created the button here, and I'll go back to the code in a second, but I'll just show you what it does. So here we have a button said Edit Operation Basic, and the idea is that I'm going to create a fire station in the middle of the map, and I'm going to create a buffer around it just by using this polygon layer that I have here. So if I simply click on it, I can see that I get two features being created, and if I look at the attributes, I have a fire station with no attributes and a precinct with no attributes either. So let's just take a look at the code on how that actually ran. And here I'll put a breakpoint in. And so if I just fire that from the button again, we can see it breaks. So the top two lines are getting the actual layers that I am interested in, certainly the one that I want to create the features in. And there's a number of different ways you can actually get layers in the map. This is just one way of doing it. So getting the map, getting the layers as a flattened list, which just gives me the list of layers, regardless of any groups happen to be. I'm saying of type feature layer, and then I'm using some lambda statement to actually find the fire stations. We won't be concentrating on that syntax too much. The next code here, qtask.run, is fairly interesting. You'll see it's a lot in snippets and examples. So you're probably aware that Pro is actually multi-threaded. It exists to the user or even the developer as two main threads that are actually running. One is the UI thread, which is where all the UI happens, all the dialogues, all the panes and so on. There is also what we call the background thread or the worker thread or the main sim thread. And what this command here does is it says put the following code on this main sim thread, on this background thread. The thread itself is actually a thread pool. Internally we manage them, so we just work out which actual threads are going on, and then we maintain all the caches and so on. But you'll see this a lot in the syntax that we use. It takes a bit of getting used to if you haven't used it before, but you'll see it basically everywhere in all the samples we have. Anyway, so what I'm doing is just putting all this code on that background thread. So getting back to creating a fire layer or a fire station. So I'm creating a new edit operation. I'm giving it a name to appear on the undo stack. I'm getting the center of the map, which is where I want to place the point. And then I say editOperation.create. I'm giving the parameters here of the fire layer and the center point. Let me just run through that so we can see these happening. So I get the two layers, and I'll put my breakpoint down here. And so edit operation, edit operation center point. And I say create, so the center point is created for me just as a map point. Go to create, and then I create the buffer polygon by saying another create operation, the layer that I want it to go to, and then I'm using the geometry engine just to create that buffer. And I'm not going to go into the geometry engine. It's got a lot of methods and properties to help you create geometry. In this case, I'm not getting it from a tool like a mouse or whatever. I'm just actually generating that buffer. Select modified features to true, and then I'll do the execute. The other syntax that I have here commented out is if I wanted to use a template to create the fire layer, I would just say the layer get template, the name of the template. And then one of the create overloads is to use the template rather than the layer itself. And that'll just start using the template's attributes when I actually create that fire station. Okay, so it's modified, execute, and I probably should have moved the map when I did that, because I probably should have lots of points here. Yeah, so I've got a point generated and the actual the buffer as well. And that's really all it is for the simple basic edit operation. Once again, lots of samples, lots of snippets out there to take a look at. All right, let's move on. Oop, I didn't do the chained. I didn't do the chained. Let's take a look at the chained operation and see what this does. And I'll just run through that. Okay, so what the chained operation does for me is it creates a precinct, but it also creates for me an attribute or record in this change history table. So when I created that precinct, I said fire stations and gave it a no ID and so on. So if I just pan across and do that again, you can see it creates two rows. Let's take a look at the code and how we actually do that. So chained operation, let me put the breakpoint here and I'll run that. Sorry for flicking backwards and forwards between the maps. Okay, get the same layer, the fire stations. I'll run through the first edit operation, which is simply just creating the fire station. This one's a little bit different because what I'm doing is I'm going to create some attributes on the fire station as we do it. So this is just a simple dictionary with the field names and also their values, which we're actually going to obtain. And one of the create overloads is taking the layer and that dictionary of attributes, and here I have that mysterious action which is going to return to me the OID that the create will create, if you like. Won't actually get it until the execute is run, so it's still -1 at the moment, and then I run the execute, and hopefully it's got a number, 37. Now I want to create this entry in the changes history table, but I want to do it in one operation because when I undo, I want to undo both the point and the row that I have in the change history table. So how to do that is I can find the table first of all, and I have a checker to see if it's actually there or not, and then I'm creating this chained operation. So it's simply create chained operation on the existing edit operation, which is already run, and then I got a reference to it, and then eventually I can put in some attributes to what I want to put in that table, and then simply say create in that history table the dictionary of values that I have, and then execute that operation. So what I should get there again is that point with the attributes on it, and then the entry within the table there. And if I undo that, then I should see both the row and the point being taken out. Bring it back, code the point in the same place, so you can't really see much difference. But the idea is it's in one edit operation. All right, let's move along to Inspector. So the Inspector class is another class within the editor which we use to access and update the attributes, including the geometry field. So any attributes that we have on an existing feature or a feature that we may want to create in the future, we can generate an inspector for it and then use that to use in the editor itself, or use in the edit operation. Typical usage, we instantiate a new one like you do with the edit operation. It starts off being empty, of course. We then load into it the attributes that we want to access or the ones that we want to update. So there's a method on that called load or load async. Once we load the feature into it, which is typically by a map member and an OID, we get access to the attribute. It contains a bunch of attributes. This is stored in an attribute dictionary. Any joins on the layer, they also come across and we can access those attributes as well. The syntax we use to access those attributes are simply by a common dictionary syntax. So we just say the inspector and we use the key, which is the field name, as a string, and then we can either get it or set the value that we actually want to get at. If we modify those fields, we simply change it on an edit operation with EditOperation.modify, and then we pass in the inspector that we've created and filled with the attributes. Typical usage, example here, QTask run, edit operation, we create a new inspector, we've loaded in with point layer number 28, the OID. We then say the root number is then 42 and the building name is building 1. The geometry line we're saying we're setting, we're getting the geometry as to say, so we're saying the inspector.shape, get the geometry from that particular feature. We might use it somewhere else, or in this case we're just setting the geometry of that feature to something else. So it might have extended a feature or did a buffer on it, or who knows what. So now we just say the inspector.shape equals the new geometry. To put that, to make that edit actually happen, I just say EditOperation.modify the inspector, or whatever I called it, and then execute, and it goes ahead and updates those attributes with whatever I specified. Notice here in that previous example I was using an edit operation to actually perform the edit. That's useful if you're using other methods in the edit operation. So you might be creating the feature and then updating its attributes, or there's an easier way to do that, or what other operations you actually have. If the modifier is the only thing that you're doing, the other syntax you can use is just create a new inspector, make the updates, and then use a method on the inspector called apply or apply async. And that'll simply just create its own edit operation, make the changes, and then close the edit operation at the end of it. The the name that gets applied to this edit operation is feature update or feature attribute updates, and that's what appears on the undo stack. So that's just, you see it sometimes in the examples and snippets. Multiple features, so if you're updating multiple features with hopefully the same attribute value, you can certainly load those into the inspector. Syntax is map member, load in a list or a collection, I should say. It's usually an IEnumerable of long, which is the OIDs. How you get those, you can get it from a selection, you can get it from a row cursor, which we don't talk about here much, but I think Narelle uses it in an example. And then once you've loaded them all in, hopefully they have the same field. In this case, you can see the example facility ID. We're just going to set it to the same number, and all those facilities will get that attribute on inspector apply. You can also work it with EditOperation.modify. In this case, I'm just using the inspector apply here. You can get the schema from the inspector. If you don't want to actually load any attributes, you just want to get information about the attributes themselves. You just say load schema, and then once you've got the attribute collection through the inspector, you can just look at the individual properties of those attributes. So if it's read-only, what the alias is, has it been edited, and so on. So that's a handy way to get at information of the attribute itself. All right, let's do a quick demo of the inspector. So back to my map, let me do an inspector modify. So this is expecting a selection. So let me just select a simple fire station here, and we've got some existing attributes. And I think in this demo, I'm just changing the district. Let me close this table. This the district attribute here. So if I run inspector modify, I'll take out the breakpoint. And so I've just taken the station number and said district is now precinct 80. So if I select another one, hit modify, it does the same thing. So let's take a look at that code. It's very simple. So I'll just run that again. Oops, I didn't want to run chained. Let me select U and say inspector modify. Okay, so now we come to a breakpoint. So what I'm doing is updating that selected record. And as I said, one way to get the selection of the map is simply use the map method get selection. What this actually returns is a dictionary of map members and the OIDs that are involved. So here I've got a count, and if I can dig down further, I can see what the OID is of that particular record. I then want to update this particular feature. So then I'm saying create new inspector. Let me load it in with the first record out of that selected set. Now this is a bit of a canned demo, so I know the first feature is going to be the fire station. Normally you may not, and you may have to filter that to get at the particular map member that you're interested in, or use a row cursor, which we don't really cover here. I'm saying get the value of the current station there just from the inspector, so that should be a number, 152, and then I'm saying set the district to be equal to this string, which is the precinct plus that. I'm doing it through an edit operation, I'm giving it a name, modify, and execute. And hopefully that should work, which we know it does. Oops. Ooh, that's interesting. Description there. Sorry, I was getting thrown by that because I'm on the wrong table. There it is, precinct 182. 152. So if I undo that, of course, it's on the stack, so that's happily removed. If I just do another example here, I'm saying inspector apply. It's just doing the same thing, but the only difference in the code here, if I take a look at it, rather than using an edit operation, is I'm simply just using the inspector apply method. So new inspector load, same code, and inspector apply at the end. And if I take a look at that on the undo stack, it simply just says update feature attributes. So if I undo that, it goes away and comes back. Oops, did not do it, comes back. So that's all inspector is. Obviously there's a lot more to it, but we just covered the basics here. All right, let's take a look at row events, or events in general. So a big part of the editor, SDK-wise, is looking at how the data changes basically while you're making edits. And you look at these events for various things, obviously to make changes to rows that are changing perhaps, or to record them for auditing purposes, or to validate the rows that have changed. There's a bit more options now that attribute rules are out there, but in this session we're going to actually take a look at the row events. So the three that we get, the create, the change, and the delete, and then the edit operation events themselves. edit completing, edit completed. At 2.6, which is coming, we've also added a new one called edit started, and that occurs at the start of the edit operation, but we won't be covering that here. Row events. So how we subscribe to a row event is we do it on a layer basis. So we're only interested in a row event for a particular layer, and we specify it by the type. So it's usually row changed, row deleted, or row created event, and we subscribe to that per layer. So we're not broadcasting events all over the place. We only want it specifically for the layer we are interested in. It's important to know that row events occur while an edit operation is actually running, whether that's a custom edit operation that you have created or any one of the core tools, because they also generate edit operations as well. What do you use row events for? As I mentioned, obviously perhaps to change the row that's actually been coming in. You might want to change a different attribute, for example. You might want to validate the row events or the row attributes that are coming in to say, well, is this a real number that the user has typed in or it has been generated? If it's not, we can certainly cancel that row event. What we're actually doing is we're actually cancelling the whole edit operation which is driving it. Another use for it is logging edits. So people like to record changes that have been made to their data. So we can certainly set up to do that through the row events. You notice in the previous example I used a chained operation to do that. Narelle's going to show an example of where we use a row event to actually do that. Changes to the row become part of the ongoing transaction. That's important because, as I mentioned before, it happens during the edit operation. So anything you do here is going to be part of that existing edit operation. It's going to be undone if you actually undo it on the undo stack. So that's important to realise that. The parameters, the variable that's passed back to you during a row event is a row changed event args. This obviously gives you access to the row being edited. So if I created a feature and I listen to a row created event, it's going to give me the row back that was actually created. You get passed back the edit type. That's only really important if you're pointing the row events to the same delegate. Normally you don't really look at it too much. The important thing at 2.4 that we added was the edit operation itself. This is the edit operation which is currently running and we pass through to the row event. This means that you can use the methods on the edit operation to make further edits, and that's really important because the edit operation maintains obviously the undo stack and the caching and so on, but it also gives you access to other workspaces. And they become part of the edit session and also a part of the edit stack. You can cancel the edit through the row change event args just by a method on that. We'll go a bit more into the edit operation a bit later on. Here's an example of a syntax. Here I'm subscribing to the row changed event. This is an inline syntax which I don't really use that much, but it just gives you an example of what's happening. So I'm saying subscribe here to the crimes feature class, and then I'm doing an inline, I guess that's an anonymous method, to actually say what I'm actually going to do during this event. I'm returning the row changed event args is passed back to me through the RC variable here. So I'm here just saying the row has the value changed. That's a property on the row for this particular field that tells me that it has changed. Then I'm doing some sort of validation district code, which is not shown here, that's somewhere else. And I'm saying if that doesn't pass validation, I'm saying cancel the edit because I'm saying why that actually cancelled. So this is an example of just running that particular validate as a change event. Edit operation row events, mentioned it briefly. Again, it's important to remember these occur while the edit operation is executing. The edit operation passed to the event. Use the current edit operation to modify the current row. So I can certainly use the methods on the edit operation to do that just by modifiers, etc. The other way to do it is just simply through the core data API, where if I've got the row and I'm changing the row, I can just simply use that syntax. It's a bit like the inspector where you say row my field equals whatever the value happens to be. It's really important to remember that if I'm editing data outside the current workspace, and you may have a history table somewhere else, use the edit operation because that will ensure that that workspace is included in the edit session and included in the undo stack. If I was just using the regular core data API to do that, it wouldn't be. And so that can get pretty frustrating when you undo and certain things don't undo. couple of rules to follow. Because we're already inside an edit operation, don't create a new one. Bad things will happen inside the row events, and certainly don't execute the current edit operation inside the row events. When the row event's actually finished and you've queued up additional commands, when the row event returns, then the edit operation will finish its execution and hopefully done all that you asked. Here's an example on row changed. I'm getting the args. I'm not going to go through this code here, but it's important to be aware of reentrancy, because if I'm making a modification to the row that's coming in, I'm going to fire another row changed event. Narelle hopefully will talk about this during a demo, but I'm just going to brush over that code. But here I'm just modifying an attribute on the row that's coming in, giving it the username. Whoa, sorry. And then I'm adding a record to this table, which just happens to be in my map. So I'm finding it, much like the previous example that I used, setting up an attribute dictionary, and then using the operation which comes in from the row to create a row basically in that history table itself, using those attributes. Notice that there's no execute and no new edit operation there. So just to highlight a few things again, row event callbacks are called on the QTask thread already. So notice in that code that I didn't actually set up a QTask run block there. It's already happening. You can specify, it doesn't really change anything. No need to store row changes either. So there I was making modifications to rows. Normally, if I was doing API changes through the geodatabase or the core data, I would have to say row store. In this case, I don't have to. It's just part of the existing edit operation. Nothing bad will happen if you do, but there's no need to actually do it. Okay, edit operation events. These are global, so you don't subscribe to a particular layer. You just say the event and then subscribe and then give it the delegate. And this happens for every data set, if you like. The main one there is the edit completed event. This is fired after an edit operation is executed. Whether it be an edit operation that you create or any of our core tools, they also fire edit completed as well. It's also fired for operations that you may not think about, like save, discard, undo, redo, and there's also post and reconcile as well. Fortunately, the arguments that are returned from edit completed contain the type, so you can actually see what's happening, whether it's an operational or a save or discard in particular. The other thing that's returned is what was created, modified, and deleted during that edit operation. So you can start to look at things that have changed during my edit session. We don't yet have the data changes interface from the old ArcGIS days. We haven't brought that across yet. When we do, that'll be a far better way to actually track data changes. Edit completing is an event that we added recently, and that fires just before the edit operation returns, so before the execute, if you like, and then you can do some additional work in there. All right, so now I'm going to pass over to Narelle, who will do a demo on editing events.
All right, thanks, Sean. As you can see, I'm here in ArcGIS Pro, and I have a project here that has the Portland data. We have a number of different polygons with precincts and a number of different points which represent police stations. I'm going to go ahead and subscribe to a number of the editing events. The first one will be the on row created for my police station data. And in that particular event, I'm going to do a spatial overlay with the precinct data. And within that row created, I'm going to fill out the precinct field on my newly created feature. I'm also going to add a record into the change history using the edit operation that comes through in my event args. The second event I'm going to subscribe to is the row changed event for my precinct polygons. And in that particular event, what I want to do is allow any attribute to come through, but I'm actually going to cancel any spatial edit. So from the user point of view, that means that they can do attribute edits on the polygons, but they're not going to be able to move or change the shape of any of those precincts. And finally, I'm also going to subscribe to the edit completing and edit completed events so that you can see the order that everything appears within the stack of the eventing. So over on my Add-in tab, I have two buttons, one to subscribe and one to unsubscribe. And just to make a note that it's also really important when you're writing your code that after you've finished with your doc pane or your buttons or whatever, that you actually unsubscribe to your events. Like Sean mentioned, the eventing and the messaging is really actually quite chatty. And with ArcGIS Pro being such an edit-centric application, it's really important that you're only listening to the events for the context that makes sense for your tools or construction tools or doc panes. So I'm just going to click the hook event button and my breakpoint goes off in Visual Studio. And really all I'm doing here is retrieving the two layers that I'm interested in, the police layer and the precinct layer. And then I jump to the background thread and go ahead and going to subscribe into my row created event. Again, because we're chatty a lot, the row created and row changed events are subscribed only for particular data sets. So in this case, I go ahead and get my police layer, retrieve the feature class of that police layer and use that for the feature class that I'm using to subscribe. I also return a subscription token, and I will show how I use this subscription token when I go ahead and unsubscribe for these events. Then go ahead and do the similar thing for the row changed event. This time I'm going to get the precinct layer feature class and subscribe to the row changed event using a different delegate. I'm going to use the on-row change delegate. And then finally, like I mentioned, I'm going to subscribe to the edit completed and the edit completing events, both being global events, so I don't need to provide any feature classes to those event subscriptions. So now, when I go ahead and choose a construction tool from my police data, I would expect that my row completed event is going to fire. And it does. And so let's take a quick look at the event args as we come into this method. You can see that my edit type is create. I have a GUID, which happens to be the GUID of the current edit operation. I have the row of my new feature, and we actually have the new property on the event args, which is the current edit operation. So as I move through this event, I'm interested in retrieving the point geometry of my newly created police station, and I'm going to use that to do my spatial overlay against the precinct layer. So I want to make sure that I actually have a precinct field in my police dataset before I do anything. And now I'm going to construct my spatial query filter, assign my point to be my filter geometry, assign my spatial relationship to be within, and then go ahead and search the precinct layer using that spatial query filter. If I have some results, I'm going to go and find what that current district name is. You can see that I happen to be in the North Precinct. And then I'm going to use the data API to assign that particular district name back to my precinct field. Go ahead and store that data, and then finally add my audit record. And I'm going to use the existing edit operation of the args to do that auditing. So again, go ahead and get what table I'm in, and you can see that I will be in the police data. I'm going to go ahead and find my change history layer that's in the map, the table, set up my particular set of attribute values, and use the edit operation that's currently in progress to execute a create on that change history table. Finally, after that, we get our edit completing event coming. Let's take a look at the args here. Really, all we have here is just the edit GUID. And then we have the edit completed event. We have lots of different options on this particular event args. We have what type of operation it was. Do I have any creates? Yes, I have one police station record created. I don't have any deletes. I don't have any and I also have a modify because I made a modification within that police station when I modified the district name. So now, when I go ahead and look at my police station data, you can see I have a new record added. The precinct has been set with the value that it appears in, although none of the other attributes were populated because I didn't populate them. And when I jump over to my change history table, you can see I have one record in my change history. Now let's go ahead and look at how the row changed event ArcGIS works. I want to select a precinct, and we're going to go ahead and jump to the attribute tab, and I'm going to change one of the attributes. We'll start with changing the area. And hit the apply button, and you can see I come into the row changed. Guard against the re-entrancy. In this particular instance, I'm using the GUID because I know the GUID is unique for the edit operation, and so I'll check that I'm not actually coming in on a row changed from the existing edit operation. I'll assign that so that I don't re-enter. I'm looking for the shape field. Remember I mentioned that I want to allow attribute edits but prevent any geometry edits. So the first thing I'm going to do is look for my shape field and then check whether any edits have been made to that shape field. In this particular instance, all I did was change an attribute, so this function is going to return false. So I'm not going to cancel the edit's going to go ahead. I'm going to again modify a field using the data API, and then again call store. Sean mentioned I don't have to call store, but what I'm actually going to do is call store so that I can show you the re-entrancy. So now, after I've called store, we know that the edit operation has actually tried to execute again, and so my row changed has come back in. Now, how do I know that I'm actually in the same edit operation and trying to prevent? I'm going to use this GUID operation argument to check against my existing GUID. I'm still in the same edit operation, so the args.guid is still going to be the same value. And so in this particular instance, I'm going to pop out of this row change because I don't want to get into an infinite loop where I'm continually modifying the same field all the time. Now this is one way to check against re-entrancy. There's a lot of different ways that you can do it. Maybe you are only interested in modifying one particular field, and so maybe your check against re-entrancy would be which field actually changed within the row changed. It all depends on your particular scenario against what your check against re-entrancy is, but it is something that's very important because otherwise you can get in an infinite loop where you're continually just going through row changed all the time and you'll never jump out. So now I've jumped out, but the next thing I want to do is go ahead and add my audit record again. So in this particular instance, it's the same as what we did in row create. Find my change history, set up my dictionary of values, run the queue up the create, and then the underlying editing code performs the execution for me. Again, edit completing comes in. One of the options here is to actually go ahead and cancel the edit, and then my edit completed. In this particular instance, we can see on my ArcGIS that, again, I have a create within the change history. I have a modify on the Portland precinct. And now when I go ahead and look at my precinct, you can see that my modified field has been filled out, and I also have a record in the change history. Finally, I want to try and show how I can prevent spatial edits. So I'm going to head and use the move tool, try ahead and move this particular feature. And again, my row change comes in. Doesn't matter whether it's an attribute edit or a spatial edit, you'll always get a row changed if you subscribe for that particular data set. But we can go through our check here and say, have any values been changed for my shape field? And in this particular case, the instance returns true. I'm going to cancel my edit to say no geometry edits are allowed, and I'm going to exit out of row changed. So now when I look at, I throw up an error message, and we'll also see that the move function actually throws up a little warning as well, saying that my move has failed. So in that particular scenario, I've allowed any type of attribute edits on my polygons, but I'm able to prevent spatial edits. And finally, we'll just go ahead and show how to unhook from all of these events. And this is where I use my subscription token that was created when I subscribed. And all I need to do is just make sure that my subscription token is non-null. If my subscription token is null, that means I haven't subscribed. So it's important to sometimes use that so that you can check whether you've already subscribed to an event before you unsubscribe. So again, go ahead and use the subscription token to unsubscribe, set it to null, and the same thing for the row changed, the edit completed, and finally the edit completing. And that's our demo on row events. Back to you.
Thanks, Narelle. So in that quick session, we talked about edit operations, the basic workflows and usage. We looked at the inspector, how we use that to access and update attribute information, and then we concluded with a brief look at the edit events available to us with a pretty good demo. The session itself and all the data and all the code that we use will be available on the Esri pages. Here's the QR code if you're using that, or just the web link itself. And as we said, the session will be available there. And obviously we're also available for questions on GeoNet itself if you frequent that as well. Okay, thank you very much. End of session. Roll credits.